Let me share my screen. And here we go. Let's get the right presentation this time. Go full screen and get to the top. So here we go. Gives me a second here. All right. You guys see the screen okay?
Yep. Yes.
Okay, very good. Let's go ahead and kick off. So my name is Scott Unger. I'm a channel account manager with InfoBlox. I've been with the company for 10 years. I actually have a very similar background to Jimmy with respect to my security heritage. I worked at RSA Security for many years. I worked at Fortinet for many years, and Cisco actually as an overlay specialist, just like Jimmy. How many years were you at Cisco, Jimmy?
16. I just left a couple quarters ago. Yep.
Yep. On the security team. And then Mike McIver, who's running our demos, was at Cisco 19 years. And I had 8 years at Cisco. But don't hold all that against us. The bottom line is we have a lot of security background and we should be able to run a good session for you guys. So that's this introduction. A little bit on InfoBlox. So I'm going to make an assumption that you folks have some level of familiarity with InfoBlox. This is not a DDI presentation, meaning DNS, DHCP, and IPAM. It's really meant to focus around DNS security and go deep there. But I do want to just front end talk a little bit about the market and a little bit about DDI. So the company's been in business for 20 years, and we've had phenomenal success with the very largest customers in the world. You think, our acronym government companies, the tier 1 service providers, 95% of the Fortune 100. We've been seeing a big movement downstream into the market, meaning that we're seeing medium-sized customers buy our technology. And why is that? The reason is because of what's happening with respect to customer networks. The amount of devices that people are supporting is going through the roof. You look at the Internet of Things and IoT devices, the amount of DNS traffic is going up exponentially. The amount of IPs you need to manage is going up exponentially because of that. And the complexity of the networks is going up as well. So think about running applications in the public cloud that has its own separate DNS infrastructure. And then you're running Microsoft and Bind and F5 and other things internally in your network. And all of a sudden I'm supporting 6 flavors of DNS. That's problematic. And then on top of all that, there's a need for automation, which is really a play for the data center people. So it used to be back in the day, we just pitched the network team. We just talked to the networking people, and we had a nice value there for uptime services and reliability and ease of management. Now we're really seeing the security pieces, the data center pieces, and the cloud pieces become holistically important to the customers. And there's another really cool thing, which, considering we have a county of on the call here, is that we have a new cloud-based system, which is much less expensive. We started at $1,000 per location with our Blox One DDI solution. And then we can actually run the DNS security functions in the cloud as well, which is called Blox One Threat Defense. So we used to have a price barrier for smaller customers, and that's gone away as well. So that's just a little bit of background on what's going on with InfoBlox as a company. The bottom line is we are positioning a system to run DNS, DHCP, and IPAM that has much more functionality than spreadsheets and Microsoft and whatever you're using today. And the main topic at hand is DNS security, because that's a red hot topic with customers. So let's just jump through here and talk a little bit about why DNS, DHCP, and IPAM is so important to a customer. So we'll role play something out. Let's say, Darlene, you accidentally get malware on your device, be it a laptop or a PC, and you come into the office and you don't know that there's malware running on that device. One of the first things that device is going to do, unbeknownst to you, is it's going to try to talk to a command and control server. Call that C2 or CNC server. And the whole purpose of command and control is to give an instruction set to an infected device. What am I supposed to do? Well, maybe that instruction set is to go east-west in the network and capture data. So in this scenario, when your device talks to thief.com, where this DNS server is hosted, DNS is used. You are doing DNS communications. You are looking for the IP address for thief.com. Given. When you go east-west, when that device tries to connect to an accounting server or tries to get intellectual property, whatever it's doing east-west, DNS is used in east-west traffic. And then once there's something on the device that the malware is collected and it wants to exfiltrate it, it's going to look for an exfiltration point. And what the bad guys are doing, and you'll get a real clear picture of how this works by the end of this, is they stand up DNS servers on the internet that aren't really used to serve DNS. They're just veiled data collection servers with query logging turned on. And they're looking for an infected device to do DNS queries to it. And they cache all that information. And then they rehexify those DNS queries into data. Once again, DNS is obviously being used when you talk to a DNS server. What's the point of this? This is the cyber kill chain models, if you ever look at this. If we're doing the IP address management, I know everything about the user. I know it's Darlene. She has this IP address. She has this MAC address. She's Wi-Fi connected here. She's connected to these servers, all the way up to the backbone, the router, and the switch. I know everything about you on that network. I can then take, so we use an indicator of compromise. The system will look at it, will say, at 1 o'clock in the afternoon, it looks like Darlene was speaking to a command and control server. It looks like she was speaking to a Chinese hosted data exfiltration server. Take that indicator of compromise or that IOC and feed it to a whole bunch of ecosystem-based partners and have them take automated action on it. Because we're a network-centric company. That's our heritage for 20 years. We're doing your DNS, we're doing your IP. We have all this phenomenal metadata about the user. And then we can go to your firewall and say, hey, looks like Darlene's doing something bad. She shouldn't be doing this. Take an action, firewall block it. Scan it with your scanner like a Qualys or Rapid7. Do a network emission control with something like Cisco ICE or Forescout, right? Package it all up in a nice ticket and send that to ServiceNow. And actually, Mike is going to do a 5-minute demo that shows you exactly how that process works in the demo section. So we see the indicator of compromise, and then we start kicking off all these automated actions. And one of the problems that people have, particularly, I'm sure a county is a great example of this. You don't have an excess of IT staff. You don't have a massive security operations center that's looking at your threats. You need something that's going to automate responses to this. And if you are a larger company that does have a security operations center, you can't get to all the issues in time, right? They only respond to like 4% of the threats daily that come in. How long is it going to take you to figure out what's going on? You need automated, quick responses that make your existing system smarter. So that's the feedback we got from a CIO from a big casino that's making a big investment with us. He came out on the main stage at our national sales meeting we had not too long ago. And he said, I'm buying InfoBlox because I'm going to use you to run DNS and DHCP and manage my IP addresses, but I can use DNS as a utility to make all my other existing security investments smarter, because you're going to see it first. You're going to shut it down at a DNS level before it even becomes web traffic. It's never going to hit the firewall. The DNS query goes to thief.com. We say, hey, that's no bueno. Stop it, right? It's killed right there. It never becomes web traffic, never hits your firewall from that point forward. Okay, any questions? I'm going to pause here. Covered a lot of ground quickly. Any questions? Jimmy, you'll be doing your slides in a couple minutes here. So, okay. So if you look at what the SANS Institute says at the bottom, I love this quote: the inclusion of DNS, DHCP, and IPAM data should be a security requirement. We need user context and device context for incident response, right? And this reinforces what I said on the previous slide. It takes too long to figure out the who, what, where, when, why. Well, we have all that if we're doing DDI for you as a customer. We have all that audit trail information if you have an incident, you have incident response going on. So this brings you to the philosophical question. Can I get by with just using my firewall, which has some measures of DNS control in it to protect us from a DNS security standpoint? And this is what we want to just, maybe do some education around this. Reputation-based, knowing that, say, thief.com is a bad place to go, whitelist, blacklist, worked years back. It was sufficient. What the bad guys are doing now is they're standing up DNS servers to target specific customers. They have unique IPs, they have unique .com addresses, and they're not on the whitelist, blacklist. And port 53 DNS traffic has to flow. In that scenario, when a day zero environment from a security perspective, the DNS traffic is going to flow, right? And there's even steps worse with this, which Jimmy's going to drill down a little bit more on, where there's fast flux, where you can change the IP address, and domain generation algorithms, which Jimmy's going to talk about and Mike's going to show in there. The point is that reputation is no longer enough to say that I'm defended from a DNS perspective. What our customers are saying is they're saying it makes sense to have InfoBlox as a DNS server run reputation, behavior, and signature technology. So that being said, I'm going to turn it over to Jimmy to take the last couple slides before the demo. So you got the mic, Jimmy.
Yeah, thanks, Scott. So to Scott's point, we know about certain known threats, and we use the same traditional ways to stop that with signatures and reputation feeds. But what we want to focus on is the machine learning, the day zero threat. So that next slide, basically, these are the threats that we're really good at stopping. If you could go to the next slide, Scott.
Yes, sir. Here you go.
Thank you. So these threats, these are the advanced persistent threats that are using DNS, port 53. These are the threats that will evade traditional layers. There's a whole bunch of malware that a firewall might be able to catch. In fact, 91% of all malware will launch from DNS. So somebody goes www.infoblox.com, they're making a DNS call. Most malware will do that, and we'll catch that. But these attacks, these advanced persistent threats, are the most problematic that your traditional layers will not catch. And that's one of the primary reasons that customers purchase our Blox One threat defense solution. And so the machine learning models that Scott was just talking about, in comparison to using traditional methods, is what's necessary to recognize something like a DNS data exfiltration attack that uses a DNS tunnel. And here in a minute, I'll go through a couple of these examples. But most of these on this slide will require machine learning models, because a signature or a reputation feed won't stop it. So the way the Threat Insights engine works, which is our engine that will help with some of these more problematic attacks, is it has the ability to block these threats based on understanding a certain maybe file size or certain geography. And so malicious patterns, requests, et cetera, that we will recognize because we train these machine learning models. Because we see every DNS request that comes through, we know exactly what it's supposed to look like. So these machine learning models are trained, they're patented from InfoBlox, and they're really effective at stopping these day zero threats. We'll talk about a couple of these right now that are more problematic. But DDoS is another thing that we do a really good job at blocking. Volumetric attacks, when someone is trying to send an amplification flood to take down a server. It's real important to have technology that specifically addresses that. And that's what we do with our advanced DNS protection solution. So the message is these attacks, they're not going to be prevented by the firewall, by the web proxy, et cetera. And that's what DNS security is for, because we see every DNS request. We have great visibility, and we have an ability through our Threat Insights engine to train these models to recognize malicious patterns, and then apply a threat score so that our customers will know what they are and what they're not. So let's go into a couple of them. So DNS data exfiltration is something that Mike is going to show here in a couple minutes. It's going to show you a demo of exactly how a hacker would do this, but at a high level, similar to anyone clicking on something they shouldn't click. And then Scott gave an example a little earlier about how that looks, but to go a little deeper, when somebody installs malware on an endpoint, the first thing that endpoint's going to do is it's going to make a command and control call back to the attacker server, as Scott was explaining. And this attack works a little bit like the analogy I use is if you're trying to steal a car out of a garage, but you can't open the garage door, you'd have to break it down into smaller parts and fit it through the window, and then put the car back together on the other side of the garage. Is kind of like what happens here. So once the malware locates sensitive data like credit card information or personal information, it will break that into DNS queries, into small chunks, and it'll take that over port 53, DNS port 53, in the form of a DNS query. And this will look completely legitimate by the firewall. Most firewalls will just allow port 53 unchecked, and this will get through. And then it will terminate as a DNS tunnel, and then it will be put back together, recrypted, recoded back to its original form. And again, we'll show you, we'll go a little more detail, but this type of attack is extremely common. The bad guys have figured out that they can bypass these traditional layers by using trusted and open port 53. And so that's why it's necessary to have these machine learning models. And then the next example is very similar, but it's called domain generated algorithms. So basically what happens with this one is an attacker configures malware, again, to go back to this attacker infrastructure, a command and control server over DNS. And so one good example of a domain generated algorithm is with the SolarWinds attack that most of us have heard about by now. The Sunburst malware actually did exactly that, used a DGA. So a domain generated algorithm is basically an attacker. He will generate thousands of domains, register only a few of them, and use the rest of them as a distraction. And they're very hard to detect. They have longer, more random characters, and they are very difficult. They're always changing. They'll use something that Scott mentioned, fast flux, which is an ability to change an IP on the fly. And so it's very difficult. These will not be caught with the traditional known methods. And so these machine learning models, again, are trained to detect this type of behavior and identify it and block it. And so that threat insight engine is really where our competitive differentiator is, so that we're not going to have to rely on our signatures and our reputation feeds. We can rely on that. And so that's just another example of a threat that is difficult to deal with. So let's go ahead and let me give you, before I hand it over to Mike, we've talked a lot. Scott and I have talked about security best practices. We've talked a lot about how attacks work. We've talked a lot about our ecosystem. But let me kind of tie it all together into our product called Blox One Threat Defense. It is a hybrid architecture which can be on-prem, which is especially useful for our existing DDI customers, and it also can be in the cloud. And it is a license that will include all of the components on this screen and more. And some of those we've talked about. I'll just cover those real briefly. We haven't talked yet about roaming users, especially with work from home and COVID. There's a lot of remote users that are no longer behind the defenses that they were behind. Maybe they're no longer behind a corporate firewall, et cetera. And so we have this roaming lightweight agent that can be downloaded on a Mac or a PC, and it just acts as a forwarder for those roaming users, no matter where they're at, so that they can participate and get forwarded to the cloud and have all these same protections that we've been talking about. We talked about the threat insight engine. That's the machine learning models that's included in Blox One Threat Defense. Ecosystem, Scott did a great job explaining that, but it's really unique. There's been too many vendors, too many silos, too many logs events, not enough people, and it's very difficult to do incident response. And so with our ecosystem, as this slide shows, we can take a threat event and we could forward it to Palo Alto, and Palo Alto can create an ACL on the fly. We can send it to Cisco ICE or another network admission control solution, and they would know to quarantine that infected endpoint or disallow that endpoint from getting onto the network until it's been scanned by a vulnerability scanner. So this ability to forward that threat event to them so that they can apply their own security policy with our security ecosystem is included in Blox One Threat Defense, and it's extremely helpful to reduce network complexity and to ease management burden and start looking at a lot of this in one single pane of glass and making sense of all your threat intelligence, all your security events, et cetera. So Tide and Dossier, basically, we also take in diversified threat feeds from internal and external sources, and we can even use customers' custom feeds that they're already used. And the benefit of that is you don't have to toggle between different vendors and different management planes. You can look at all of your threat intel at one place, and we gather that information, we curate it, and then we create a super feed and send it to the ecosystem so that that additional information will be there as well based on those different threat feeds that you use. Dossier is like a Google search engine for bad actors. So Dossier is a great tool where you can go in and get a lot of valuable information like the who is data, who registered this domain, when did they register, did it come from Russia or China? And so not only can you see the threat intel in there, but you can see all this registration data. And again, the security operations, the SOC teams love this because we had one customer say that they reduced 20 minutes per man hour was saved by using Dossier. And so, yeah, as you take a look at the portal, which is our CSP Cloud Services portal, you start to see how all of this comes together on one single pane of glass, and that's really what our product is built to do. It's built to reduce network complexity, give you guys an ROI to security. Since the last 5 or 10 years, you've been buying all these different vendors, these different management interfaces, et cetera. It's become really just a kind of a train wreck of multiple vendors, silos, et cetera. So that's a little bit of an overview of some of the components. And let's get into showing you exactly what it looks like.
Mike, you got the floor.
Any questions while Mike is taking over and going to show a demo or two? Anything? I know Scott and I are covering a lot of information in a short period of time. Any questions? Okay, Mike. Or should I call you Bob?
Mike, you're muted. Because I know he'd be talking by now already.
All righty. Can you hear me now?
We can hear you now.
There we go. So what I'm going to do is take you through a real quick sampling of an ecosystem integration and show you how the things work together a bit. And keep in mind, this is just a sampling. There's over 80 different security vendors that integrate with us. But I think one of the key process or items here is that we have a pretty open API here where we're able to push information out to security tools, whether they're on our list that have already done this or not. And when we talk about ecosystem partners, the integrations have already been done. So they're pretty easy to deploy, implement, and get running for you. And we're going to do this by walking through a story. And we're going to start with Bob here. And Bob's not protected, and Bob's working at home because of the pandemic. And while he's at work, you know, like all of us, he's been home for a long time, and he's dreaming about going to Hawaii for a vacation when the COVID restrictions lift a bit. And so on one of his breaks, he goes out to a website, and what he's going to look for is, you know, what a flights cost to Hawaii right now. So he goes to his flying site, and look at there, there's an offer you can't refuse. So Bob clicks on it. It loads this little application on. Microsoft warns him a little bit, but he still thinks it's good. Clicks on it, and look what he gets here. He gets this message saying, you've been hit with ransomware. And when he goes out and starts looking at his files, what does he see? They've been encrypted. And so Bob's been a victim of ransomware that easy, that quickly. And this stuff happens all the time. Now, if Alice is in the same situation and she's running BloxOne Threat Defense with BloxOne DDI, she goes out and actually does the same thing. She's going to go to Fly Easy. She's going to click on the same link, but this time she's going to get this splash page. And what's going on is InfoBlox saw that it was a malicious site, and it blocked it. And instead of giving her the IP address back of the bad server, it gave her that splash page going, you can't get there. Either it's a bad site or security says you can't go there because it's something that we're blocking. Now, in the back end, let's look at what's going on here, right? She did her request. InfoBlox picked it up and sent her the splash page. But at the same time, all this stuff went on in the background. It went out to ServiceNow and it created a help desk ticket. It went to Splunk and did the whole ticket for Audit Trail. It went to Fortinet and did some things. It went to endpoint scanners and got them fired up. And it did it all automatically with no human interaction. So if we go to ServiceNow and look, we can see that this client tried to go to a bad domain. It was blocked. We put in an RPZ on the Fortinet firewall. We started scanning with Tenable and Rapid7, and we logged it out to Splunk. So this is all right in the service ticket if you happen to be using ServiceNow, showing all the key information that any group would need from a security standpoint to follow up on this. Now, if we go to the Fortinet firewall and look down at the bottom, here's the InfoBlox RPZ, which has a deny in for this bad site's IP address. So now everybody else on the network that's going to try to go there, it ain't happening because the firewall is going to block it at a IP level, which firewalls do very, very well. If we go out here and look at the tenable scan, we can see that there's one actually going on right now for Alice. And there's been an RPZ, and it's a blocked domain, and so there's some information there. Rapid7, if we go down through here and also look, we'll see that a scan's in progress. And by the way, when both of those are complete, they'll also update ServiceNow and Splunk to show that they've completed successfully or if there's any issues. And if we look at our IP address management database, right, we can go in here and we can start looking at data management, and we can look at the network and start tracking down what happened and where it happened. And this is pretty traditionally how things are done. And it's simple, but through doing it with APIs, what we're hearing back from customers is that, number one, because we're putting all the information right here in the service ticket or in the Splunk ticket, and we can click hotlink, on any of these, it's saving them about 60% of their security analyst time on any indicator of compromise. And if we start going in and doing some looking here, right, we happen to use Splunk for a reporting engine. We can go in here and we can start seeing what kind of information we have and what else may have been affected in the network. So if we look here, we can see that I have a source of UDP 514. It's a JSON script. My client IP, it's a Windows computer, the name of the machine, what URL it went to, all of this stuff about the endpoint. And that's pulled out of the IPAM database, right? When we're handing out the DHCP addresses and we get to know what that endpoint is, we store that information. DNS gives us the information about where they were going to. So it's all this great, rich information that we can use to make the security and analysis of this issue much faster, much more complete and robust. Now, once we have some of this information, we can start doing some data pivots and start looking at things. So here we're looking at Alice's computer. We can see that she went to FlyEasy, that it went to Copalter. You know, we can kind of track what actually happened. And when we want to start looking at Copalter, we can start doing some security pivots and have some more interesting information. And that's where Tide and Dossier come in. So now we can look at Copalter for everybody on the network. And this will let us know if anybody else is affected, if there's east-west traffic going on within the network, all tied to this Copalter site. And we can see here that one machine on the network has been communicating heavily with this Copalter site. In fact, it's 4,200 packets or DNS requests out to copalter.com. I can probably assume that that's a data exfiltration. And let's say we just use 23 bytes as a DNS request times 4,200 packets. We can actually determine that there's been a fair chunk of data that's been spit out of our network into Copalter that we may or may not want to go there. So again, just a ton of information, and everything I just showed you was done automatically. And then we can do follow-up with the security architect teams, and using things like Dossier, we can even prioritize them so that we're showing critical events versus nuisance events. So that's the first quick demo. Again, it's representative. It does not cover everything by any stretch of the imagination, but it's a great place to start and get an idea of what's going on. With that, I'm going to pivot here into another demo to show you. Now, this one is something that if you want to try in your own networks, you can work with your team here at EdgeTeam or us, and we can actually go and get you access to this tool for 2 weeks so that you can try it on your own, or have them come out or one of our own account teams come out and work with you on running this. But it's called DEX, which stands for Data Exfiltration Tool. And I'm just going to go sign in here. It's just a web browser or a website that has put things together to make this very simple to use. And first thing we want to look at is, let's talk about data exfiltration at a very basic level and how it works. If I am this user on the left here, right, John Smith's computer, and I get infected with malware or ransomware, first thing it's going to do is it's going to try to find its command and control server, which in this case is over here on the right side of the screen. And all this is it's a DNS server that's been spun up in AWS or Azure or something like that. And its only purpose in life is to do something called query logging, which means every DNS entry that comes into it, it's just going to record. That's all it's going to do. Now, once it's got all those DNS entries in there, it can do some other things like put them all back together and unencrypt them. But it does that through DNS query logging. So everything I'm talking about is just DNS standard stuff. There's nothing out of the ordinary going on here. Now, when John Smith's computer tries to get to what we're going to call thief.com over here, he can't talk directly out to the internet. So he's going to go to the corporate DNS server or your local DNS server and say, hey, I need to talk to thief.com. And the DNS server, being a DNS server, is going to say, well, I don't know where that is, but let me go up the hierarchy on the internet and find it. And it's going to send this request on up the hierarchy. Somebody's going to know how to get to thief.com. Going to hand it back to the corporate DNS server, which is going to hand it to John's computer. And at that point, he can start sending DNS requests out. And if we look under number 2 here, there's a bunch of numerals and there's a bunch of characters, .thief.com. That is a standard DNS request. But everything before the .thief.com is actually data. And what I've done is I found a file I want to take out of the network. I've converted it to hexadecimal using operating system tools, and then I've chunked it up into bits that are sized right for DNS queries. I put thief.com on it, and I send them out. They dutifully get handed off to the DNS servers over to the target DNS server, who just stores them using query logging. And then once I get them all here, I can put them all back together, hexify them, and hand off the corporate data to the bad DNS server. So that's kind of how the process works, and it's explained here when you go to try that. But let's look at something a little more fun. Let's actually do some of this. So in the data exfiltration toolkit here, I've got 3 of them. I've got text decoder, script decoder, hexify, and then I've got this thing that shows what I've been doing. I'm going to start with text decoder because it's a great way to explain how this works and actually show it. And I can just say, hello, everyone. How's the weather in New Mexico? Now you can see as I type this up here, down in the gray box, it created these NS lookup strings. And these are a standard DNS query. And what's been going on behind the covers here is I literally took this text and converted it to hexadecimal and then split it into a standard DNS query. And you can see just something the length of this takes a couple queries to send out. And I can actually choose what kind of DNS record type I want to send it out to. And I can, if you look here, it says type A. I can change it to type MX, text, CNAME, whatever I want to do. Now, I think it's important that you know that because we found that with some of our competitors, they'll take the top 3 record types and they'll do some extra looking at that to determine whether they're good or not. But they're not looking at all the DNS record types. And so if I'm a hacker and I'm thinking of things like a hacker, I'm going to try all of these to figure out if any of them get through. And if they do, I'm going to take advantage of that. So now all I've got to do here is grab this DNS query. And just to show you there's no smoke and mirrors going on, I'm just going to go out. I'm working on a Mac laptop. I'm just going to go to my command line here, and I'm going to paste this in and hit enter. And look at here, server can't find this DNS request. And so it gives me back this NX domain. And an NX domain is just a DNS server saying, I don't know where this is. You have to try something else. The key thing to notice here, though, is everything before is still there. So remember, this is data, right? This is data I just sent out. And if I go back here and look at the last gray box down here, we can see that, hello, everyone, how is the weather? I got the WE out of weather in the first DNS request. And if I want to complete it, I can just go down here and cut and paste the second request in. And we can see here, I get the same thing, right? I get an NX domain back, and we'll give it just a second to update here. And what'll happen is, there we go. This has now gotten to this remote DNS bad server out in AWS, which is what box 4 here is actually looking at. This is just monitoring that bad DNS server to see what we got out there. So I just did a very simple data exfiltration using DNS queries. Of course, hackers aren't going to do this command line. They're going to do it with scripts. So we give you the ability to try this. So I can do something as simple as go out here to my desktop. I'll just grab a little PDF file, and I can put it here and say generate a script. And it will go down here and create some scripts for me. I've got a Perl script, a Unix shell script, or a Windows PowerShell. So depending on which one you're comfortable with or what kind of machine you have, you can pick and choose. And if I grab this one, because I'm on a Unix box, and I copy this out to my command line, the only thing I have to make sure that I do is that I'm in the proper directory with the file that I'm trying to exfiltrate, and I paste this in here and hit enter. We can see that I am starting to just blast out DNS queries, right? And they're all going to this JS barbecue supply, and I'm getting NX domains back, but these packets are flowing, right? So if we go out here and look at transferred files and messages, we can see that today at 12:07 my time, because I sit in Arizona, I used the DNS text decoder and sent this to the bad DNS server. And now I can see that I'm running a DNS script decoder, and I'm writing smart goals out, and 169 of the 510 DNS queries that need to get there to transfer the whole file have happened. I can hit refresh and see that they're updating here, and they will continue to do so until that entire file is out here. Again, thinking of this a little bit more like a hacker, and even with 400, let's see, I should be able to pull up the file, right, most of it. So here's what I sent out. This is just a PDF talking about SMART goals, which, if you don't know, is a way to come up with time-bound, realistic goals for yourself. I've got most of the file out here. There may be a little bit that hasn't come through yet, but this was all exfiltrated and put together using DNS. Having said that, let me move something here so that there we go. Let me go back to the script decoder and show you. So I already showed you that we just blasted these DNS requests out, and somebody in the audience may be going, well, if I'm just doing this one after another, then I should be able to find this stuff, because look at it. Look at this pattern. It's just very simple. And that's true. There are some things out there that will pick up this stuff. But keep in mind that these are going out, even though I'm sending them one after another, there's hundreds, thousands, millions of DNS requests going on out of your network on a daily basis. So these are being interdispersed within all these other DNS requests, which obfuscates this a little bit more. But let's go back to thinking like a hacker. I know that there are things out there that will catch this. So I'm going to do something that's going to make it tougher. And Jimmy talked about domain-generated algorithms and fast flux and things like that. So I'm going to click this algorithm up here that says new, that bypasses signature detection. And I'm going to regenerate the script. And what I want you to notice, right now I've got highlighted 4 lines of code. I'm going to hit generate, and now I'm looking at 8 lines of code. And while I'm not going to bore you with all of this, because this is going to take a little bit longer to run, I am going to copy this out here to my command line and show you what happens that makes this different. So I've got my code out here, and I hit enter. And what we'll start noticing is, first of all, the packets aren't flying out the window, right? They're going out a little bit at a time. The next thing I might notice is, look at here. Here's an A record. Here's an SRV record. Here's an SOA record. So I'm changing record types, right? I'm not keeping those consistent. If I look at the domain names, here's JS Barbecue Catering. This one's going to Double Barbecue. This one's going to From Pandemic. So now I've actually got multiple domain names in there. The packet format, or the DNS query format, looks a little bit different. And so all of this stuff is things that hackers use on a general basis to get around signature and behavior-based algorithms. And that's where our machine learning and heuristics come in, because we're sitting there looking at the internet as a whole, looking for behaviors and processes that look very much like this. And we're able to pick up those day zero attacks. And the beautiful thing is, once we see these, we can turn around and alert your firewalls, your endpoint scanners, and things like that, and make them work better. So we're kind of the first line of defense. We find these things faster. And the reason that's important is most malware starts doing data exfiltration within 24 hours of it being put on a network. Most security tools don't find those at a packet level until something like 180 days. So if I'm spitting stuff out like this, every couple seconds for 24 hours a day, 7 days a week for 180 days, I can actually exfiltrate a lot of data. We're talking gigabytes of data out of a network just by throwing these little queries in amongst all the other hundreds of queries going on per second. And it just filters it out under the radar and nobody sees it. So by having us there as the first line of defense, picking this stuff up early and then sharing that information across your security stack, you're set to be protected much better and much quicker than you are today. And just to finish this out, we'll see we're running a script decoder. And right now I've only got 41 packets out. So it's a much slower process. And again, it's just built to obfuscate these DNS requests into the normal stream of things that are going on in your network. And with that, Scott, I'll hand it off to you.
Excellent. All right. Went a few minutes over. Hope that's okay, but I love Mike's demos. I always like to get them both in. Darlene or Matthew, do you have any questions for us that we can answer? Open table for you guys. Okay. Anything from the Edge team? Any comments?
No, really appreciate you guys running through that. We're going to reach out to, all of the webinar attendees today through both sessions and see if, there's any follow-ups or questions, that people, pop in their head a little bit later as they're kind of thinking about digesting what they just went through. And, again, great webinar, both sessions, and, good stuff.
Right on. Yeah, we'll get you the recording as well as the two different decks since they were different for the two sessions, and we'll get that sent to you on a G drive. And thank you for your time. That's a wrap, guys. Thank you again.
Appreciate it. Like we talked about, I'll add those to our webpage for us, send that out to